So the next and last video in exercise 7A is finding exterior angles and finding other angles, okay? So this is probably the trickiest little part of this exercise. I much prefer myself doing these ones. I really like these kinds of problems, finding unknown angles. But in this case, we're going to be finding exterior angles using the exterior angle theorem. Well, what is the exterior angle theorem? Well, it looks like this. The exterior angle theorem works like this. If you get given an exterior angle to solve, so I've just highlighted that in green, and you want to go, okay, what's that exterior angle? Well, a little trick to find that angle, and this is what the theorem states, if I get my internal angles, C and B, that are over here in the triangle, here and here, if I add these together, I get my exterior angle A. So the equation for it is shown below. If I get my angle B and add my angle C, I get my exterior angle A. So we're going to use this information, this knowledge of the exterior angle theorem, to help us work out y in this case. So off we go. Now we know that y is our exterior angle, and to work out our exterior angle we can use the exterior angle theorem. The equation we use for this is A is equal to B plus C. So let's write that out now. A is equal to B plus C. Now, not to be confused with Pythagoras theorem. So A is our exterior angle. And you might see here we use the same letter. In this case, our A, see how they match up, is now known as a Y. So instead of writing A, we're going to write Y. We're using a process called substitution. Now, this bit is a B, so let's label our diagram and say that also is B. And this is our C, so let's label that as C. Now let's use substitution to swap out B with 55 degrees and our C with our right angle. Now we know a right angle is 90 degrees, so let's plug in C as 90. Therefore, using the exterior angle theorem, we can see that 55 plus 90 will make this outside angle. And it looks quite obtuse to me. So 55 plus 90 is 145 degrees. And there we go. We've got our exterior angle as 145 degrees. Solved it. The next question, and we'll do the your turns after this, is part B. Now part B here looks a little tricky. So these ones, you just need to plug in as much as you can to help you find the value x. Now in this case, we need to work out x, and we're given this information. This side here this angle here is 47 degrees, and we've got a triangle here. So I hope you can see that. So we've got a triangle there, and we can see that this length here is equal to this length. Now if we go back to our triangle properties up here in our worksheet, where did it go? There it is. We can see that if we know two sides of a triangle are equal, then it's a isosceles triangle. We also know that if it's an isosceles triangle, we can say that this angle and this angle are the same. So we're going to do the same thing here. If it's an isosceles triangle, we know that this angle here, which I've drawn a dot on, is the same as this angle there, which I've drawn another dot on. So therefore we can write 47 degrees. Now, if this is 47 and this is 47, what must this angle here be? Well, let's just figure that out. So we don't know what that is yet, so we're going to put an arc there, and we're going to go, okay, let's just call it A, because it's an unknown. A plus 47 plus 47 has to equal a total of 180 degrees, because it's a triangle, right? Let's bring our terms together. And then we need to subtract off 94 from both sides. Therefore, A is equal to, and we can put in our calculator, 180 minus 94. Press execute and we get 86. Now, we haven't figured out x yet, but now instead of the A, I can rub that out and I can just go, that there is now 86 degrees. Now, we need to find out this x, and we've got this angle here. Now, I'm reminded of a certain rule that we learnt about before in our angle properties part. Let's have a look up at our angle properties. Let's see if any of these can be used. Well, it's not complementary or supplementary revolution, but these are vertically opposite angles. So we can see if we have two straight lines, then this angle, 130 degrees, is the same as this. So we can say that these are going to be the same. Therefore, x is equal to 86 degrees. And we can use the 3 dots. And we can say in brackets, because of the opposite angle. All right. Now, we can pause, please pause the video, and I want you to have a shot at these triangles on the right-hand side. Once you're completed these, press play on the video, and then see if you got your answers correct. Once you're finished, we'll be working through these questions shown below. So, we're going to go through the your turns now. So we can see here that we have our triangle shown over here, and here's our exterior angle. So I'm going to label that with an A to match the A from up here. Now let's go across, and this is the top part, and this is along the straight line. So if we follow along the straight line, the 70 degrees will be the B. And if that's the B, C is going to be that angle. So it's like the triangle's been flipped. So let's use our exterior angle theorem. A is equal to B plus C. And then we sub in our values. A in this case is 152 degrees. It's equal to B, which is 70 degrees, plus C, which is X. Now, we need to get X by itself, so let's use SADMIB and take 70 from both sides. What do we have left? Well, we have 152 minus 70, which makes 86 degrees. Not quite. Don't know what happened there. Oh, I don't think I was clicking properly there. And we've got 82 degrees. There we go. So 82 degrees is equal to X, and I like writing it with the X on this side. So X is 82 degrees. So that there, 82 degrees. Now part B, we're going to look at this one here, and we need to solve what Y is. So let's have a look. Well, we've got this angle here, 40, and let's just plug in as much as we can. Well, if this is 40 here, we can see this angle will be the same. So what we're going to do is say this here is 40 degrees. And I might use a different color because the diagram's in blue and it's just a little bit confusing. So now we've found this one here. Now, what else can we do? We need to find Y. It's a little tricky at the moment, but we've got this here, and I'm going to highlight in green. Oh. I've got this angle here. Now, this may remind you of a supplementary line or a straight line. So we know that the full angle from here all the way to there will be 180 degrees. If this is 120, what must be left over? Well, this bit will have to be 60 degrees, because 60 degrees plus this chunk, 120 degrees, makes 180 degrees. So we're going to put in, and I'm going to do this in red, a 60 degree line there. Now we need to work out this angle here. See how we're moving towards the Y? Well, 60 plus 40 is 100 degrees. 100 degrees plus this angle would make 180. Therefore, this angle here will be 80 degrees. So we're just filling in as much as we can. If this is 80 degrees, then we need to find out what Y is. And we have another one of those supplementary lines. So we know 80 plus y has to equal 180. Therefore, and let's just write that out, 80 plus y is equal to 180. If we take 80 from both sides, then we know that y would have to equal 100 degrees. And there's our answer. So please work through these questions here. If you do have any questions for me, please let me know, and best of luck for today.